Hello. In the last video, we have established that Python is a very popular choice for data science. In this video, we will look at some of the libraries we will use in the course. This is, of course, a trailer to what is coming, but also provides you some more insight why the different components of Python come together in it being a very successful data science programming choice. Let us first look at IPython and Jupyter. These provide interactive ways to use Python not just as a scripting language, but something that you can play with, incrementally modify and see the effects of. Here is a screenshot of a terminal which is running IPython. In the first line of code, I have declared a variable name with the value padhai. It is a string object with the value padhai. And in the second line of code, when I type in name dot, trying to access some function that is provided by this string object, I can press tab and see all the different options that Python provides for me. So clearly this improves programmer productivity. And remember, all this is happening within the terminal itself. This kind of an interface also goes by the name of REPL, R-E-P-L, because it has a read, eval, print loop within IPython. But essentially for a programmer, what it means is they can write code quickly, they can print out values, and they can prototype multiple ideas much faster than actually writing it in a text editor, compiling the code and seeing things. This is IPython. The next similar idea, but a much more broader vision, is that of Jupyter Notebooks. This is a screenshot of a browser page where Jupyter Notebook is running that is connecting to a Python kernel. So Jupyter provides a web-based interface for different programming languages to connect to and provide interactive programming as a front end. So in this case, you see that the notebook shows code. These different inboxes have the code. The results of the code are printed below, and you can also have things like titles and text written which can explain these ideas. So you have a notion of a notebook whereby you are not just writing code and seeing results, but more or less documenting the code on the go. And this idea of a notebook was first proposed by Mathematica. I greatly admire this software. Already in the 1990s, they had this interesting idea that programs should be like notebooks. You should write your intuition, you should have sections, then you have code, and then you have plots and so on. And all this should be mixed within the same interface. And the IPython and Jupyter libraries enable that for Python. The next important library which we will see and use quite a bit is NumPy. NumPy is short for numerical Python, and when we use it in practice, we in fact shorten it even further as NP. So you will see most programmers using NumPy as NP. And here I have a few lines of code to explain what it does. I have in the first line of code imported NumPy as NP, this shortened version. And then in the second line of code written something like A is np.identity3. So in a sense, I'm asking it to create an identity matrix of size 3 by 3. And now when in the third line I say A enter, in the out of that, I correspondingly see a matrix, which is the identity matrix of size 3 by 3 with ones on diagonals and zeros elsewhere. So NumPy provides us an ability to load, store and process high dimensional data. In the previous example, you had just a 3x3 matrix, but even high dimensional data of maybe 4 or 5 different dimensions can be stored, loaded and processed efficiently. A good picture to have in mind is something like this, where data could come from 3-dimensional data, and you can take projections of data in different dimensions, and all of these, which are typically called tensors, can be stored and processed with NumPy. So NumPy provides the ability for Python to work on numerical processing of large dimensional data. The second important aspect of NumPy, which is actually a great benefit for data science, is that NumPy arrays are used as common interfaces for low-level implementation. What does that mean? Let us say I have a Python program which has a NumPy array defined, and I have a C program which is doing something interesting, maybe interfacing this to a low-level hardware. Somebody has written an interface in C. It is possible to expose to the C program the NumPy array as it is without having to copy and store values again. So NumPy becomes an interface to go outside Python and also still efficiently process numerical data. This greatly helps because, as you have seen, the development of data science software has included multiple people coming together and building different components, and NumPy array can act as an efficient interface to pass high dimensional data between these interfaces. Okay, that is NumPy. I think one important inspiration for NumPy has been MATLAB, which was founded on this whole idea of working with matrices. So I think with NumPy, Python can somehow match most of these ideas of MATLAB. Of course, MATLAB is much broader now. It has ability for you to program constructs for different domains. Let us say whether it is electrical engineering or mechanical engineering, you have specific modules for them. But in essence, the methodologies that are provided through NumPy enable us to build many of these things within Python. Okay, the next important library is pandas. In fact, it is probably the most important library we will see throughout this course. It is shortened as PD, just as NumPy is shortened as NP. Pandas is shortened as PD, and in fact, it started not too long ago. It started only in 2010, just the last decade. What does it do? It provides data structures and functions to manipulate structured data. So structured data is when you have relational data that you can write as a table. So each row is one data item with different relations given by different columns. And such structured data, how to store them, how to access parts of them, and how to have functions that operate on them is what pandas specializes in. In particular, we will be looking at two common objects. One is a data frame, which is what I talked about. How do you store this relational data? And the other one is series, which can be helpful in modeling time series data. Let us say a stock market moving up and down, or the measurement of blood pressure for a given person across days. So pandas helps us to model both of these types and also process on top of them. Just recall again that the course has been structured around 5 different tasks of collecting, storing, processing, describing, and modeling, and pandas plays a very crucial role in these 3 middle ones of storing, processing, and describing. Pandas will be our mainstay library, and hence we will focus quite a bit on that. And again, from an inspiration point of view, pandas started out in 2010. I think a good inspiration for it has been the R programming language, where it has tried to model these data frames. And in fact, pandas, even in the naming of some of these words like data frame, etc., takes inspiration from R. And I would contest that today, Python with NumPy and pandas can replace most of the functionality of R programming language. The next set of libraries is for visualization. We will use matplotlib and seaborn for visualization. And they are the default visualization tools in Python, and they work very well together with Jupyter notebooks. We have seen that with Jupyter notebooks, you can execute code and see the output inline within the web interface. And the matplotlib and seaborn plots can also show up there, and this enables one to have a single window to explore all of these. Here is a screenshot of plots drawn with matplotlib, and I think this is matplotlib. As you can see, variety of different plot types are there. There are scatter plots, there are line plots, there are box plots on the right there. There are also more complex plots that we will see throughout the course. And as we have mentioned, communication forms an important component to data science, and matplotlib and seaborn will be our libraries to go to for that effective communication. Again, from an inspiration point of view or a feature comparison point of view, tools like Tableau, which specialize in visualization, are what inspired tools, libraries like matplotlib and seaborn. The idea is to be able to support a wide variety of visualization formats while keeping configuration values very compact and easy to use. Again, from a feature perspective, I think Tableau has some more advanced ways of plotting, but matplotlib and seaborn are sufficiently rich to meet most requirements in data science. One more library is SciPy. It's a bunch of useful components to enable scientific computing with Python. So as we have seen here, again, these are the 5 different components of the course, and both describing and modeling will be something that we can take help from scipy.stats. So SciPy provides modules for, let us say, signal processing, linear algebra, and so on and so forth. But particular for us, scipy.stats provides lots of library functions for describing data, for modeling data, hypothesis testing, regression analysis. All of that can be done with scipy.stats, and we will be using that in most of the second half of the course. And from a feature comparison point of view, I think MATLAB also, as I said earlier, provides multiple components for different domains of engineering, and SciPy tries to provide those features within the Python open source environment. Finally, there is scikit-learn. It is the go-to library for machine learning on Python. As the word learn says, it is for machine learning. In this particular course of Foundations of Data Science, we will only towards the end look at linear regression, which is the idea of fitting a linear function to input data. In this case, you have x as input and y as output. I would like to find a good linear representation, if one exists, between this input and output, and you can use scikit-learn for that. Scikit-learn, of course, is much more powerful, providing a library of many machine learning tools, and this will be the important topic that we will cover in the next course of the series on machine learning. But at the very end of this course, we will look at linear regression, and at that time look at scikit-learn. So with that, we have seen the most important libraries that we will use in the course. In the next video, I'll summarize what we have seen so far and also give you some tips on how to go about these programming sessions in the future videos. Thank you.